Hello. Hello, everybody. My name is Smoggy. And hello, my name is Breezy. Ah, what a beautiful day. Fresh air, blue skies. Why, bro? Why would you inhale that? Huh? What? It's just air. Free air. The best kind. That's not just air, that's air with ingredients. Ingredients like oxygen, nitrogen, more like nitrogen oxides, sulfur oxides, particulate matter, and a hint of car exhaust. So, seasoning. No, poison seasoning. Wait, so when cars, factories, and power plants release stuff into the air, that's air pollution. But I can't even see it. Exactly. Sometimes air pollution is invisible. Sometimes it looks like smog. Sometimes it just makes your lungs angry. So, air pollution isn't just one thing. Nope. It can be gases, tiny particles, or chemicals. It can come from human activities or natural sources like wildfires. Yep, volcanoes too. But humans really are efficient at polluting the air. So the big question is what's in the air and how does it affect people, ecosystems, and climate? Pollution that this is a topic that really is huge for us in the LA area. We kind of lead the world in we led the world in realizing we had a problem and then taking steps to do something about it. And as we go through this unit, we'll see a lot of things that are very effective at reducing our pollution that's in the air, and then still have a lot of room for improvement. So we're going to look at all these things, looking at the sources and effects of air pollutants. I think normally we think of source of air pollution, we think of cars, and that is the primary source of air pollution. But there's many others that are out there that affect us. Some that might surprise you, and the effects of air pollution, which we kind of discount a lot, but air pollution does have serious health effects that can ripple through the economy and the general health of our population. So let's get into it. I found this diagram. I came up or introduced this idea of an airshed earlier when we were talking about watersheds. So these kind of are the airsheds we have in California. They're called air basins, which agencies in California have regulation over these geographic areas that tend to be connected in terms of their air. So they all need to be considered closely when it comes to how pollution sources are emitted. So we are in the South Coast air basin. So starting with the first essential knowledge, specific to coal combustion. Now we talked about coal combustion. There's not nearly as much coal combustion as there was, say, 20 years ago or 10 years ago. It's just become less cost efficient to do it, but it's still used. The main issue is a lot of carbon dioxide is released into the atmosphere when coal is burned or combusted. Also, a big one for acid rains, sulfur dioxides, toxic metals, and then particulates. Acid rain is a big thing. Carbon dioxide, global warming that drives so many of our topics. Metals like lead and mercury, birth defects, and other health, negative health implications, and particulates for very hard on our respiratory system. and we'll get into that later. Here's kind of all fossil fuels together. Carbon, hydrogen, oxygen are the two main ingredients, but there's nitrogen and sulfur, both of which these nitrogen and sulfur atoms contribute to acid rain. And that problem in itself has gotten a lot better in the last 20, 30 years. But the main pollutions you can see here, volatile organic compounds. You open up anything and it smells, that's an organic compound. The scent of any kind of industrial product like paint, solvent, all the way down to household items, cleaning things, air fresheners that people use. Those are volatile organic compounds that we're putting in the air. Here's something you'll see, PM10, PM2.5 particulate matter. It's usually when we get into trouble, it's from this PM2.5. And these are small enough they can get into your blood. Will go through your lungs and into your blood. So digging deeper into fossil fuels, combustion will release nitrogen oxides. I'll just cross that out. They will create ozone, which is O3. Photochemical smog, and convert nitric acid in the atmosphere, causing acid rain. So nitric acid, sulfuric acid, those are the two kinds of acids we're looking at with acid rain. And carbon monoxide, which can poison you. This is carbon monoxide. Every once in a while, we'll see deaths from this. People will burn fossil fuels in enclosed spaces, and carbon monoxide can build up and basically suffocate people. People pass out and then just die. Hydrocarbons and particulate matter. And that's, when you see the smoke coming out tailpipes of trucks or diesel vehicles, that's what you're seeing. That's really bad to breathe in. Here's a fun little guide, kind of peruse. I mentioned carbon monoxide, carbon dioxide for global warming. Both carbon dioxide is poisonous to us. Carbon dioxide isn't, unless you're in a real bad situation under super high concentration. Nitrogen oxides, mostly for their acid rain effects, and along with sulfur dioxide. Ammonia, that can be very irritating. As you know, I think you all understand ammonia is a very dangerous chemical for you to inhale or, get into your body. Volatile organic compounds like paints, other industrial chemicals. Ozone can be formed, especially from electric motors can create ozone. Copy machines create ozone. Like if you don't go to a copy machine in an enclosed area, you can get ozone. Ozone is created when you shoot electricity through the air. It can bond three. It's basically, oxygen is usually O2, two oxygens together. Ozone is O3. And the persistent organic pollutants, particulate, and heavy metals like lead and mercury. Now I want to take a close look at this. And this is what I mentioned earlier. We don't often consider the economic burdens of air pollution. But if you look at this diagram is from 2018. So China in 2018, it's calculated 6.6% of their gross domestic product. It costs that share of their gross domestic product to deal with the air pollution. So what I did is I went down, I looked for the United States, and in 2018, our gross domestic product is 2.66 trillion. And I grabbed the calculator. 3% of 20.66 trillion is $61 billion. We don't get that bill, but we all pay for it in hospital visits. And when you're in the hospital, lost work. People are sick. They can't go to work. And this leads to higher prices. Taxes can go up. Fees for a lot of things because people can't do it. You got to go back and repeat it. So it's a big impact, $61 billion. Like $661 billion is about what the entire agricultural and maybe the tech industry altogether is worth about $61 billion in California. So it's a lot of money. Even though we're looking at trillion, $61 billion is still a lot of money for us to sustain. Sometimes people don't think about it unless it costs them money. So the more we can emphasize that, dirty air costs us a lot of money, that could be something that changes people's mind because people get so darn political about it. So let's go through more of this economic cost that I just pointed out. So loss of your life. So you can't, so there's 5 years you can't work, you got to retire early. Think about all that money you can make during that time. Replacing people with substitutes, wage losses, everything like that. Agricultural, it definitely has a negative impact on agricultural yields, air pollution. Social costs. So medical services, burden of diseases when you and your loved ones are sick with respiratory diseases that can then lead to other more serious complications. That's a big problem. Then ecological. Our ecosystem is damaged. And we know if we don't have a diverse ecosystem, that just is going to build up other costs for us. Here's some deaths. How many deaths per 100 people? I'm not sure. This would be a good thing to investigate. Why Afghanistan is so darn high. Double. Afghanistan is right next to Pakistan. Why do so many more people die in Afghanistan than Pakistan? But if we look down at the United States, 21 deaths per 100,000 people. So Long Beach is roughly 500,000 people. Let's see, in Long Beach. So that means roughly 105 people died in 2016 from air pollution. Now, that's, I don't know how many people die every year. Second. Die from, I'm running into problems with my video, air pollution. I'm not sure what the total deaths are in Long Beach per year. That's a good statistic to figure out. But 105 people dying from the effects of air pollution linked directly. That's something we really need to think about. That's, people that don't have to be dying. So sulfur dioxide, that I mentioned earlier, that greatly affects the air. And that's largely from diesel fuels, which we largely see in trucks that transport things to and from here in Long Beach, the port of Long Beach, through all the warehouses in Southern California. And it's been well established that, if you live near these major corridors, you definitely have a higher risk of cancer and other health risks like asthma. So here's a map. And it basically follows the freeways. And Jordan, we're about right here. Okay, we're along this is the 91, and this is the 710. So we are in definitely a danger zone. You can kind of see the LA River. So we'll draw an arrow. Jordan High School. Because as you know, we're right next to the 710. So that is a problem. But this is what I mentioned earlier. We have done a lot of important things, one of which the Clean Air Act has made a huge impact. Um, the biggest thing they've done is getting lead out of auto fuels. So when I was a kid in the 60s and 70s, or the 80s, then back in the 60s and 70s, cars drove around spewing lead out their tailpipe everywhere because everybody used leaded gas. And that has a very big impact on brain development in young people. Um, you just don't, there's no safe level of lead. All of any kind of lead can lead to neurological problems. So this is an amazing graph right here. As you see, the blue is the decreased use of lead in gasoline. As that drops, we see this average blood levels drops, in human beings right along with it. It goes down, gasoline goes down, lead levels, so does blood. Now, gasoline levels out or goes up, so does blood levels. So this is a closely linked thing. So this was just such a giant improvement in our lives. And this is tetraethyl lead. We see the lead, which is Pb in the middle. Tetra, meaning four. We have 1, 2, 3, 4 ethyl molecules, meaning we got 2 carbons. So this is what gets created when you burn lead or use it burn it in fuel or in paints, cans, and pipes. There was a really tragic case in Gary, Indiana, I believe, where the city stopped putting a chemical to reduce the lead leaching out of their pipes. So for a couple years, there was a lot of lead in their water. And this just has untold negative impacts. And even lead damage can actually get passed on to, like if you're a kid and you get damaged by lead, you can pass that damage on to your kids. So it's incredibly important we deal with lead and get it out of every single thing we possibly can. So lead exposure, write some of these down: lower IQ, learning disabilities, hearing loss. People are much more prone to do criminal type activity if they've been exposed to lead and be more violent. And there's also been a huge dramatic decrease of crime in the United States since lead has been reduced. And the best explanation, there's a lot of things that happen, right? It's really tough to nail down exactly why these things happen, but I feel the best explanation is that reduction in lead. And adults too can be compromised by lead exposure. So write down some of these things for children and then for adults. Check this out. Since 1980, we've just seen a huge decrease in all these major categories of pollutants, especially lead, especially carbon, sulfur monoxide, nitrogen dioxide. The one things that aren't coming down as much are those particulate matter, ozone, and both the small and the big particulate matter. So, but the trends are good. Hopefully, everybody wants clean air, no matter what. No matter what your personal thoughts or feelings are politically or socially, we can all agree on clean air. So we just have to be thinking straight and do the right thing to get clean air for us. And people complain about the cost of regulation. Well, this is, like most regulations, end up making us money in the end because they help the economy run better, more predictable, and you have fewer illnesses when you're living in a clean environment. So just look at this. These are the costs in billions of dollars. They're down here: 20, 53, 65. The benefits: $2,000 billion versus 65 billion. I mean, look at that. There's no comparison. Okay. Huge benefit. And just I want to focus on, because people people get kind of wacky. They're like, oh, I don't care about the earth, blah, blah. But most people don't want to spend money unnecessarily because we know the cost of living has just been getting worse and worse for so long. So there's two types of not two types, but two categories you need to know about are primary pollutants and secondary pollutants. Primary comes straight out of burning something or from a chemical from the wildfire, from the volcano. Things like nitric oxide, sulfur dioxide, carbon dioxide. But then after that, you have secondary pollutants. When you have the sunlight hit it and everything mixes together in a big soup, you get things like ozone, nitric acid, sulfur trioxide, sulfur acid. And we'll come back to most of these later. Okay. So with the skill focus, we need to know how changes to a procedure can change the adult. So just if we're looking at air pollution, increase traffic volume in a model is going to give us more pollutants, right? The more traffic, the more pollution we're going to measure. Sampling air at different times of the day, we're going to get different ozone levels, right? Tests at night, not that many. Middle of the day, a lot. Measuring near a forest or a park, we need to be careful. Those things can really affect the levels we see. Changing wind speeds, air pollution is really dependent on the wind conditions. And then framing it. Same different setup can give you different outcomes. So all of these different setups. So we got to just be careful how we set up our experiments and our models to take all those things into consideration. So to wrap this up, just the introduction, this is a serious problem. We saw, the deaths, 105 in Long Beach per year, okay, from air pollution. What was it? What did $60 billion? Is it 60? Yeah, $61 billion. Where am I at? Yeah, 61 billion every year we had to pay for that. Okay, so we need to learn about the sources of this air pollution, the chemistry, the weather that contributes to it, and the geography, because one thing that gives us not so good air quality are the mountains that are behind Jordan High School to the north and to the east that can trap air coming off Pacific, can just trap it, and then we breathe that in. And we're a real case study, because we have two things. We have high population, lots of people, and then we are in a basin, right? We have with mountains. Okay, very good.